Hey, so today is the third day since I'm learning Roam Render and Clojure, and today I'm going to be trying to build a table. And in this process, I'm going to be using some of the data log queries, and I have an article about this, so if you're interested, I recommend reading this. That's going to give you a good understanding. What I'm doing is I've actually split this piece into three parts, and it's going to build on one another. And also you will recognize that now my examples are filled with tags, and actually I did this for the previous days as well, so you will find the tags all over the place, and this just helps find examples of how certain functions are used, because you can just simply, if you are interested in how map is used, you can come here and you can immediately see the examples of using map. So in today's example, the first one is, so yesterday, if you remember, I had problems with getting a stable block ID. So in today's solution, you can see this on the right hand side. I've taken a slightly different approach. So what you see here is I've defined a random string function that generates a 10 long random string, 12 long random string. You can see that here. And what I do is, as I start this component, I generate this random string. You can see that right there, and I insert it as the ID of my div. And this div is buried quite deep, so you can see, well, this is a different random string because this was an earlier screenshot, but you can see how this now builds up. Up here I can see the block ID of my block, and I can see the structure under it, and here's my random string. So what I do is I've added an onClick event, and when onClick is fired, then I get my block ID. I get my block ID by accessing the JavaScript document object, getting the element by ID. My UID is going to be this generated random string. And then I move up the tree to the parent, to the parent, to the parent, and I get the ID of this parent, and the last 9 characters are the block ID. So if I click my button, then I get my block ID, and we can actually double check just to make sure that this time it's stable and it works, and I have a good block ID. Now, I could also do this without the need to press the button, but for the purpose of building the table, I actually use this button. So if I look at the Roam table, you know, you're familiar with the Roam table structure, and I can also copy this and just down here create a table for you, so you can see how this, oops, how this looks like, but I'm sure that you're familiar. So this is how the Roam table works, and this query here is a data log query. You can execute simple queries like this. I look for, so I have find, and I pull based on the entity ID of my block. I look for block UID, and this is actually now hard coded for the sake of this example. So you can see that's the block ID. It's hard coded in the query, but of course in the solution it's not hard coded. So I search based on this block ID, and then I pull is a recursive pool of data based on the entity ID and the children attribute. Each block has a children attribute that holds the direct descendants, so the children, not the grandchildren of the block. And what I do here is I pull the children and then recursively, so this is what this ... means, I continue to pull the block string and block order. Block order, you can see here, is a number that represents the sequence of the block. So this would have an order 0 and this would have an order 1, and so this is the resulting query. Now, I thought I would do a different type of table. So my table right here, and this is what I'm going to be working with, is going to look like this: column 1, cell 1, cell 2, cell 3, column 2, column 3. So it's a different table structure. And this is exactly the same query, but you can see that the structure of the result is different. So I have it here, so you can see this query has it's a vector of nested maps and vectors and maps. And so you can see that we have 3 maps here, and each of them has a vector of 3 maps within that. And so this is going to be the structure that I'm going to be querying. So that's the first example, and we are going to build on this going forward. Maybe one more thing to highlight here, that for the block ID, I'm using the reagent atom, and the atoms are, they provide a way for to manage shared synchronous independent state, and they're reference types like refs and vars. And what you can do, you can access an atom using the @ sign or the deref function. I'm going to be using @, and you can change the value of an atom using the swap function, and you need to give a function that will provide a new value for the atom. You could also use the reset function. And so you can see here the description of the swap function, where I take the atom, I take swap, the atom, and a function, and the function sets the new state. So you can see it right here that I call swap. I have my atom here, and I have this function that calls getBlock with the div UID and updates the block ID. And what reagent does is whenever the value of a block ID changes, it will redraw automatically the related hiccup structure. So moving on to the next level in this solution. Let me close that and open the next one. Not like this, but shift click like this. So what I wanted to do here is I wanted to run the query. So if I press the button, what this is going to do is this simply executes the query that I showed you before. And the way this works is, you see, it's basically the same code. Up here, this is all the same with the get block ID and the random string for my div UID. And I have added a query result atom as well, and I have this query table which takes a UID and it runs the query. The query looks very similar to the previous one, except that I'm now providing an input, and so this is how you write the input. $ stands for the database, but it is implied, so it doesn't need to be passed in as an input parameter, and UID is the input that I'm providing. Otherwise, it is exactly the same query. And what you can see here is when my query is executed, I swap the results into query res. And otherwise, the code down here is extremely similar to the previous one. On click, I swap block ID. I didn't change, or I swap block ID to get the block ID of my component, and then I call query table with that block ID, and here in the end, at the end of the div, I simply print this string. And then moving on to the last part, I actually had quite some struggle with this last bit, but it does work. So what you can see here is I have my table here, and if I click update, then you can see that my table is generated. And if now I come and show you this code, you can see that again the top section is unchanged. Also what happens here is I've added again yet another atom for table. This is going to hold my table data structure. I still have my query, and then down here I have a bit of additional stuff. I still call get block ID and run the query, and then if my query result is empty, then I print true. So that's why you saw true in the beginning, and this was just for me knowing that this is the true part of the if statement. Else it generates a table, and within the table, this is a bit of a tricky story here, but what I'm doing is I take the first, this is the first part that I'm doing right here in here. I take the query result and make it into a sequence, and then I call this function. This function threads the expressions through the forms, and it inserts x as the second item in the first form, making the list, etc. You can read this. The point, what it does, I can show you better here, is on this result, it will thread through the results through the following function. So it will first take the query result. It will take the first item in that result set. So if you look here, the first item is actually the array itself. So I'm just removing the brackets here, and that means I'm accessing the vector inside it. Then I get the first element of this, so I get this vector only has one item, so the first element actually gives me the contained map, and then I get block children. So this map actually has a single block children element, and then again I have the vector. So if you recall, in this case, you can remember this. So I'm getting block children, and then under block children you can see that I have my vector. So that's what I'm accessing here. I get to that structure, and then frankly I spent 4 hours trying to work through how to access this data structure, and whatever I tried, I failed. So I turned to trusty old JavaScript, and what I'm doing here is I'm calling, I created here a JS functions structure under the window object in JavaScript, and so this is placed in a Rome /JS code. block, and what I'm doing here is I'm processing this vector of maps into a vector that I can use to display this table. So unfortunately I just wasn't able to figure out how to do this in Clojure. I will try continue trying, but for the time being this is just my limitation. And then what I'm doing is I'm taking the resulting vector and I'm passing that vector into this map function that will first will go through row by row. So I'm getting a vector of rows here. I pass it in to this map function and print a table row, and then I again pass the row into a map function that will for each cell create a cell. Let me just push this to the right. You can see it will just simply print the cell, and with that I'm generating my table. Maybe it's interesting for you to see how I can debug, and also maybe I can show you how I can access or how my array looks like. So if I press F12, then I have my console. It's a bit teeny tiny. I'm sorry for that. Window.js functions, and so I need to open this and go to the function definition. So show function definition, and so this is my code. It really doesn't. How does it get larger? It gets slightly larger, yes. And I'll just come here to the return table, and then if I click update, this will come up, and if I press, oh, I'm right here. So this is the table that I'm returning. So you can see the way it works is it has as many elements as many rows my table has, and for each column it contains the values. And this is how then I can simply take my take these two map functions to create this table. So this is where I am in my learning process today. I hope you liked it, and I hope you've learned a couple of things. And of course the Roam graph is shared, so feel free to poke around and look at my code, and happy learning for you as well. Thank you.